Ready, guys? Yeah. Okay, so my name is Marek Kuklis. Some of you already know me. I'm a software engineer here. I also design electronics and troubleshoot a lot. We'll start the EMU PRO training. I will start talking about the hardware. The picture is from a thermal camera when we were testing the temperatures on the H-bridge. This is without the aluminum case, so a lot less cooling, but it's still reasonable temperatures. So, to power the ECU, we need constant power, 12 volt ignition, switched power, and at least one power ground. The amount of power grounds connected depends on how many loads you have, how many current goes through the whole ECU. But the minimum is constant 12 volts, switch 12 volts, and one power ground. The constant 12 volts doesn't have to be constant, really. It just allows additional features. You can have a delayed turn-off. I don't know if you have implemented it yet. I don't think so, but we will. And also, there are some values that are stored permanently in the ECU, like odometer, and it is normally it is periodically saved in the ECU. But if we have a constant power and ignition switch, if we turn the ignition switch off, the ECU saves all the values that it has to save in the permanent memory and then shuts off. The same goes for the logging on the USB stick. So it saves the data periodically, but if you suddenly turn off the ECU, it doesn't have time to save the data that it had from the last period. So yeah, using constant and switch as it's intended gives the best results. We have three types of grounds. So power ground, analog ground, and digital ground. Power ground is for routing high currents. So if we have an auxiliary output and load current goes through this auxiliary output, it has to flow out of the ECU, so it flows through the power grounds. So you take all the power grounds, connect them to one single point, your best ground point in the car, either chassis, engine. And analog and digital grounds are for sensors, and they should not be connected to the external ground. Analog ground is used with voltage signal, so we have voltage sensors from 0 to 5 volts, and digital ground is used with sensors that are mostly frequency-based signals, so all the triggers, sensors, wheel speed sensors, flex fuel is also on frequency-based signal, so it will go between the digital input and the digital ground. Two CAN buses, I have one more question. How many of you are familiar with setting up PMU or ADU? Okay, so most, okay. So like in PMU ADU, two CAN buses, CAN 1 for, yeah?
What would be the best ground to connect the shield?
Power ground.
Power ground?
Yes.
Shield?
Yeah, so with the shielding, there are emissions and immunity. Some stuff emits noise, electrical noise, and some devices are susceptible to this noise. To limit it, for example, we have one sensor, and just beside it goes current for ignition coil. If you want to shield the sensor from the noise from the coil, the noise that the coil will generate, if we connect, it wants to go back to the source. So the source of the current in the ECU is always battery or alternator. So if any current comes from battery, it must go back to battery, always. If you don't provide a path for it, it will find a way. And the point is, the noise generated by the coil has to go back to the battery. So we want to provide the shortest path for the noise back to the battery. So if you shield the sensor, and shield is connected to power ground, any noise that is generated from the coil will go through the shield to the power ground to the main chassis ground. And this will give you the shortest path for the noise go back and be dissipated. Okay, two CAN buses. First is for communication with the client application, 1 megabit per second locked. The speed is locked because we want to have maximum bandwidth for data logging and so on. If we would allow, for example, 1 to 5 on the communication bus, we would have to limit the amount of data logging we have. So this is the idea for the locked speed. And the second bus is configurable for multiple speeds and custom output and import. The new compared to black is the lean bus. We don't have specific features for it yet implemented. The idea is Bosch and Valeo have smart alternators and windshield wipers modules, which are connected through this lean bus. It's a simpler version of CAN bus. It has less bandwidth. It can be one wire. So not critical stuff in newer cars is connected through the lean bus, and we'll try to implement support for smart alternators, which can change the amount of charging they provide. Directly set the voltage that they should charge to, and so on. Flash drive USB connection for logging, the same as PMU, ADU. We have a... Yes? Oh, sorry, yeah, my bad. ADU only has, only ADU has flash drive logging, and we have a flash drive connected right here. I don't recommend using this way. I already torn the wires yesterday because the wires are very thin in those USB cables, so it's hard to crimp them. You can buy, for example, in electronics shops, you can buy socket for USB with a PCB, for example. Already with a PCB, and solder your own thicker wires, and that's the best way to do it. Okay, so here we have information that digital 5 and 6 are supporting turbo shaft speed. One more thing that is important, digital 9 and digital 10 share a pin with analog 19 and analog 20. So that pin, you have to choose, you either use it as digital or you use it as analog. And another thing is that digital 7 and 8 share a voltage threshold with 9 and 10. The idea behind it is you connect, for example, front wheels to the 7 and 9 and the rear wheels to the 8 and 10. Because usually on the one axle you will have the same sensors, the same voltage threshold, so you don't need separate threshold for those two inputs. So that's just the hardware limitation. We had to do it this way, and it is how it is. Yeah, so we have a configurable voltage threshold for each input. We can enable or disable pull-up, pull-down resistors 1 kilo ohm, configurable filter strength. Everything is very similar to EMU Black. And we have maximum voltage inputs for the digitals. Next we have analogs. Full screen F11. Okay, so we have 20 analog inputs, 16 in EMU PRO 8. Analog 1 is dedicated for map sensor. If you don't use map sensor, you can connect something else there. But if you have map sensors, it is recommended to connect it to analog input 1. It has higher sampling rate, it has different filtering. It's designed to have a better signal with map sensor. And also for the future, we have possibility to make synchronous measurement of the map sensor with respect to the crankshaft position. So we will be able to measure the map sensor at exact the same crankshaft position every rotation.
So suppose the trigger mode made on the motorbikes?
Sorry?
There is a trigger mode that made for the map sensor that controls the map sensor as a camshaft position sensor on the first crank and it's determined cylinder number 1.
Yes, yes, I understand. I think it's possible. We didn't dive into this much, but it should be possible to enable synchronization through a map sensor. So, yeah, if you have a map sensor on one cylinder only, and then we should be able to add software feature to use it as a synchronization to
Motorbikes are now implementing those kind of systems.
Yes, I understand. And also on ITB cars, it could be useful.
Yeah. We have a customer already doing that with a map sensor on snowmobiles, getting the initial sync on one cylinder in the black.
Yeah, that's. It should be possible. I don't want to make any promises, but yeah. So the normal analog inputs are 12-bit, and precision analog inputs are 16-bit. So higher resolution analog measurement, 8 in EMU PRO 16 and 4 inputs in EMU PRO 8. Those are used for mostly for EGT. So you can connect exhaust gas temperature sensors directly to the ECU. You can connect them 8 in a single-ended configuration, or you can connect them also in differential mode. So with differential mode, when you connect both pins, both terminals of the sensor to the inputs, you have much better noise rejection. So the signal is basically perfect.
So, but you are using 8 analog inputs for that?
Yes, if you use differential mode, you can connect 4 sensors. Because you have to use 2 inputs for each sensor. So you use 8 inputs for 4 sensors, or you can use connect between input and analog ground. Then you can connect 8 sensors, but you will have a little worse. You will have a little of offset, for example, and yeah. 2 NOx sensor inputs. So 2 dedicated inputs that can be assigned in software to specific cylinders. To measure the NOx level. 2 lambda controllers for LSU 4.9 only. This is on design with a Bosch chip, the same as in lambda to CAN. We can also connect external through analog inputs, external controllers through analog inputs or CAN bus. We also have a better diagnostics with the lambda sensor than in EMU Black. We can see different kinds of shorts and disconnects, and we have a state for the controller if everything is okay. So diagnosing it should be easier. Injector outputs. This is the number in the after the Pro. So Pro 16 has 16 injector numbers, and Pro 8 has 8 injector outputs. All the injector outputs has peak and hold driver for low impedance injectors. You can set the peak current, the hold current, and also the outputs, injector outputs can be used as a normal auxiliary output for any other strategies. 10 and 8 ignition outputs, active or passive coils, very similar to black. One passive coil, max one passive coil per output. Auxiliary outputs 16 and 12 between Pro, 16 and 8. Three different modes of working, simple on-off, PWM, or current control. This will come in the future, so we will be able to, for example, I know there are transmission valves that are often controlled with a constant current. So this will be a possibility to just set the current at which the output should be, what current should go through the output. Overall, the outputs, the injector outputs and auxiliary outputs have much more features than in black. For example, we have current measurement on every output. We'll have overcurrent alarms, so you will be able to see if the output was overcurrent and turned off because of it. Yeah, higher frequencies of PWM. For now it's 2 kilohertz. I think we will be able to increase it to, I think, around 5 kilohertz for PWM, but we have to make more extensive thermal tests. And the last is full edge bridges. So we have 4 or 3 of them. Can also be used as auxiliary outputs. Each output can be either high side or low side. One limitation is that if you want to use PWM on edge bridge outputs, only one of the outputs at the time from single edge bridge can be PWM. From what I remember, the outputs with the letter B can have PWM, and output with the letter A cannot. It's a little different when you use it as a full edge bridge. So if you use it as a full edge bridge, it never is, there is never a situation where you have different PWMs on both outputs. You either have a PWM output B or PWM output A. So when we control the throttle body, the PWM is switching between A or B. The same goes for different types of solenoids or so on, that DC motors that are connected to the edge bridges. And I think that's all I wanted to say about the hardware.